Okay, let's keep doing the next problem. Okay, so it's 41. So we are how many perfect square are between here, right? So we want to see basically we want to find a square is greater than, we want to see some square and another square, so then we can know that a is between the this number c and this number d, right? So we can let's do it. So 6 the fourth equal to the 36 square, and the 4 to the 6 equal to the 4 to the 3 square is equal to the 64 square, right? So now a should be between the 36 and the 64. Okay, they are all exclusively on both sides, so number of a is 64 minus 36 minus 1 equals 28 is 27. Okay. Okay, 42. So a is less than this. So compute the number of the integral values of this one can take on. Okay, let's do it. So let's convert in the middle one. Okay, is equal to, let's divide by a. So it's equal to 1 plus 1 over b over a. So you can see we have this, right? So it's less than, let's divide by 5 on both sides, on the numerator and the denominator is this, and also greater than the over. So now we can see, okay, the denominator is bigger, the fraction will be smaller, right? So now we know this one is less than this one, right? With less than this one means the denominator should be bigger than this, and the denominator should be smaller than this. Okay, now we can solve this part. Give us the b over a is greater than the 5. 2001 minus 1 is 5, and this side gives us that it should be less than 2001 over 4 minus 1 equal okay. So this is the range. Okay, next. So which one of this number is the largest, right? Still, I mean, we either make the base, make the exponent the same, or make the base the same, right? Let's write them down. So 2 to the 3 of the 4 basically is, we need to 3 of the 4 to the power is 2 to the 81, and 2 to the 4 to the 3 is 2 to the 64, and 3 to the 2 to the 4 is 3 over 16, 3 over 4 to the 2 is 3 over 16, and the 4 to the 2 to the 3 is 2 to the 8 is 16, and the 4 to the 3 to the 2 is 9, and is 2 to the 18. Okay, so we know this is the power of the 2, right? So we know this is the biggest, and for 3 this is the biggest. So now we want to compare 2 to the 81 against 3 to the 16. Okay, now let's see. So we know, let's starting from the 3 to the 16. Okay, so 3 to the 16 should be less than 4 to the 16, right? Should equal to the 2 to the 32, right? So it's definitely this one is less than 2 to the 81, right? So the 2 to the 81 is the largest number. That means the answer is this. Okay, next. So we have this one. Okay, it's still the same thing. Okay, find the linear combination over a bounded region. Okay, let's draw this region first. So we need x greater or equal than 0. That's this area. Y greater or equal than 0. That's this area, right? Okay, so 2x plus y less than 8. So y is 8. 1, 1, 2, 3, 4, 5, 6, 7, 7, 8. So x-intercept is 4, right? Because it's less than, so we cannot take anything on the line. So let's draw a dashed line. Okay, x plus 2y less than 10, so x should be less than 10, right? 4, 5, 6, 7, 8, 9, 10. And the y should be less than 5. 1, 2, 3, 4, 5. Zero and 5. So we have intersect of point P. Okay. Now we want to find x plus y, right? So for this one, the k is -2. For this one, the k is -1/2, right? We want to find a k. Our target k is in the middle, is equal to -1, right? Somewhere here. So now let's see. When could we x plus y equals c, right? So this c is the y-intercept. All the x-intercept is the same. Let's see. So we have a bounded region of here. We want to see which one gives us the biggest c, right? Our line can be, let me change another color. Our line can be like this. Can be like this, passing this point. Our line can be somewhere like this. Okay, so let's see which one can give us the biggest intercept c, right? So the biggest intercept c over this bounded region, of course, is passing through the P, right? But the problem is, let's see, if we can solve the P as the M and N, right? So it seems that the x plus y, the maximum is passing the M and N, right? So it should be like the C max equal M plus N. But the problem, okay, is this right or not? Let's see. The problem is the P cannot be taken because we are less than that, right? So we should be infinite close to P. But not on the P. Right? So M plus N is not achievable. Okay, so there is no max value for this one. Next. Okay, find the greatest value of this one. So we have an equation set 1, 2, and 3. Let's see how we can solve it. Okay, it seems that we have the AC and if we add them together, let me see. Okay, so let's see. I think we have the ADC here, right? If we add them together, we have the ADC here. Okay, so let's see. 1 plus 2 plus 3. Then we take out the ADC. It becomes the ADC is become the 2b plus c equals 0. Then we have the c equals the negative 2b, right? Because it tells b is negative. So let's try to solve everybody else using the b. Okay, so c is negative b, then apply to we have the a equals negative 3b. Okay, then we have the d equals to the c equal to the negative 2b, d equals to the negative b, right? Two. And now we have the a plus b plus c plus d equals, it is the negative 3b plus b negative 2b minus b equals negative 5b, right? Because we know b is positive integer. B belongs to the positive integer. Okay, so that's why the maximum value of the a plus b plus c plus d is equal to the maximum value of the negative 5b when b is a positive integer is negative 5. Next. So we have a set of equations and we know w is greater or equal than 0, right? So now it's w greater or equal than 0. Let's solve everything as x using w, right? We can solve x equal x in terms of the w and based on the range of the w to see something, okay? So from the 3, 2, 1. So from 3, okay, we have the z equal to the 3w times plus 2001. Okay, then we apply to the 2, then we can solve the y. Okay, so 3w plus 2001 plus 2001 equals 2y. Then we can solve the y. Y equals to 6w plus 804. Okay, now apply 1. We can solve x. X equals to the 6w plus 804 plus 2001. Then we can solve minimum of the x is based on the w greater than equal than 0 is 60 plus 8004 then plus 2001. Okay, that is equal to 3335. So this is the answer. Okay, 47. So find the value of this one, right? Okay, so this one before we always like to times something to make it to remove the denominator. But be careful when we times something to remove the denominator. Okay, so let's see. So if the denominator is -1, right? Okay, in order to make something greater than 3, right? So the numerator should be less or equal than -3, right? So that's why when we, it looks like how we get this, right? For example, if this one -1 greater or equal than 3, when we times the -1 on both sides, right? Remember, we need to change the direction of this inequality, because the square should be less or equal than 3, right? If you didn't flip, it becomes greater or equal than -3, so it doesn't make any sense. That's why we need to flip it. Okay, so when we times always a negative number, we always need to change the sign of this. Okay, so it's always, you can also understand from the number line, right? So if when we have a number, if we have a region, right, it's a positive region is greater or equal than 3, right? When we times a negative number, here is the number a, right? When we do the negative a, right, when we do the negative a is here, so it should be always less or equal than -3. So when we times the -1, it should be greater or equal, becomes the less or equal. Okay, that's why. Be careful about this. So now we need to do the casework. Case 1 is 3x plus 5 is greater than 0. Okay, so in this case, we need x greater than -3/5. Okay, then we can do the 4x negative minus 5 greater or equal than 3, then 3x plus 5. Okay, so this one we can solve is x less or equal than -4. Okay, take a look at it. We need x greater than this and less or equal than 4. So we need the x should be less than this, and this is something -1 point something, right? We need this, we need x is here, at the same time it's here, so no solution for this case. Okay, then the case 2 is 3x plus 5 is less than 0, so x is less than -3/3. Then we need to change the sign in this case. 4x minus 5 less or equal than, okay, be very careful about it, 3x plus 5. Then we can also solve is x is greater or equal than -4. So this one makes sense, right? So it's -4 and 5/4. So we needed to including this and not including this. So that's why the answer is okay. So 9.48. So we have the PQM are positive numbers. PQM are positive numbers, and the Q is less than 100. The number obtained by increasing M by P% and decreasing the M by the Q% exceeds the M. So M, if we increase by the P% and decrease the new number by Q%, we still need to greater than M, right? Exceeds the M, right? So by this, we know M is positive number, right? So when we divide a positive number, okay, we don't need to change the sign, so we know we need the P/100, okay, 1 minus Q/100 is greater than 1, so we can get 100 plus p, and 100 minus q should greater than the 100 square. Then we can expanding on this side, so it's the 100 square plus 100 p minus q, and minus pq should be greater than 100 square. That means the p, right? Okay, so we need to solve this equation. Is the 100 p minus pq is greater than 100 q, then it's equivalently to be the p is greater than 100 q over 100 minus q. Okay, so the answer is E. Next, it's 63 over the 40 to power to the 45 and the 33 power to the 54, right? If you take a look at this, so we have the 6345 and the 3354. So this one is a multiple of 9. This is a multiple of 9. So we take a look at, like, it's better to do the to do some factorization. Is 7 times 9 and to the power of the 5 then to the 9, compare with the 33 is 3 times 11, 3 times 11, then to the power of the 6, then to the power of the 9. Okay, now we know we need to compare these two now. Okay, so let's compare with this. So we have the 7 to the 7 to the 5, 9 to the 5, and compare with the 3 to the 6 and 11 to the 6. Okay, so 3 to the 6 is basically is to the 9 to the 3, right? Yeah, so 7 to the 5, 9 to the 3 compare with this. It's equivalently compare with 7 to the 5, 9 to the 2, divide by, we can divide both of them by 9 to the 3, right? 9 to the 3, 9 to the 3 is gone. Compare with the 11 to the 6. Now this is the 3 to the 4th. Okay, so now let's basically we can compare 7 to the 4 times 3 to the 4 over 11 to the 4, compare with 11 to the 6 over 11 to the 4, and divide by 7, right? Yeah. So now we can compare is 21 over 11 to the 4, compare with the 7 to the 121. Okay, so this one, right? This one, it's very, so 21 over 11 to the 4 is less than 22 over 11 to the 4 is less than, is equal to 16. So this one is less than 16, but how about this one? Is 121 over 7 is greater than 16, right? So now we know this side is bigger, right? And because we do the balance, we didn't change the sign of the balance, right? So here, this one is bigger.